Welcome to our meetup about Lambda Expressions in Kotlin. I believe that all of you already have some basic notion about Kotlin. Maybe you have already started working with Kotlin. And I hope that through this meeting, some stuff about Lambda Expressions in Kotlin will be become clearer, and you will understand a bit more about what happens behind those Lambda expressions we use in Kotlin, and of course about the possible syntax. But first, a few words about what I'm doing. I focus on delivering training for software developers. I also teach in the academic colleges, but most of my work is working with software developers in companies, delivering specific tailored training as well as public courses and public seminars. And I also have public online courses on Udemy. A bit more about the company I run, you can find in the website lifemichael.com. You can also find there information about two conferences I'm going to run by the end of this year, and I will send you free pass for those two conferences. You can also find in this link more info about my courses on Udemy. A new project I'm working on is about online courses, both in Hebrew and English. You will find in academy.lifemichael.com. Another project I'm working on is about courses for kids, both in English and Hebrew. If you have kids, then you might find it interesting. And as I said before, more info you can find in the website itself. Specific courses I recommend you to check are this and this one. And let's start. So this is the plan. I don't know if we can complete it in full, but we will try. So first, let's start with a general explanation for Lambda expressions in programming languages. Well, if you have already seen a Lambda expression in programming languages, then you should already know that a Lambda expression, when evaluated as an expression, its value is actually a reference for an object that represents a function. In some programming languages, such as Python and JavaScript, a function is already an object. So the value of a Lambda expression in those programming languages is actually a reference for an object that represents a specific function. In other programming languages, such as C#, Java, and Kotlin as well, when you write a Lambda expression, the value of that Lambda expression is actually a reference for an object that was instantiated from a class in which you can find a definition of that specific function the Lambda expression describes. Now, I want to take you back to Java. I believe, well, I know for sure that not all of you, but most of you are already familiar with Java. In Java, before the emergence of Lambda expression in Java 8, we used to use the anonymous nested class syntax. It was the only way for us to write code that will give us the feeling of passing over a specific functionality from one place in our program to another. The possibility to pass over a functionality from one place in the program to another place, such as in the case of calling a function and passing over another function to that function, so that the function we pass over will be invoked in another part of our program. This possibility is very simple to achieve when dealing with programming languages in which a function is an object, because you can take the reference for that object and pass it over. When a function is not an object, as in Java, and actually also in Kotlin, even though people might say differently, the only way to achieve that possibility to pass over a function to another place of the program is to have a class in which the function will be defined as a method, and then instantiating that class and passing over the reference for that object we got. The anonymous nested class syntax, for those who are familiar with it, was the only way to achieve that possibility to pass over a functionality from one place in our program to another in a way that will be simple to digest, simple to understand, comparing with more complex possibilities such as defining a new class and defining the function is inside that class and instantiating that class and passing over the reference for the object we got. So when Lambda expression emerged in Java 8, was actually an alternative syntax for using the anonymous nested class syntax. By the way, for those of you who are not familiar with the anonymous nested class syntax and want to have a better understanding of what happens in Java when using Lambda expression as of Java 8, I recommend you to check my course about inner classes in Udemy. Now let's move forward. In Kotlin, we continue to live in a world where a function is not an object. And in order to allow us to pass over a functionality, a function from one place in our code to another, the simplest way would be to use Lambda expression, just as in Java. A Lambda expression that eventually, and I will show you that, eventually underneath, it is actually an expression that its value is a reference for an object from a class that you can imagine that it is auto-generated for you, a class in which there is a method defined, and the code in that method is in accordance with whatever the Lambda expression describes. And we will see that. And when having that possibility to code a Lambda expression and then just pass it over to another place in our program by calling a function, and now I'm going to mention the oops. By having the possibility to pass over a functionality from one place in our code to another using a Lambda expression, the code becomes simpler, more readable, and this is the approach everyone prefers. When we talk about passing over a specific functionality from one place in our code to another, we're usually talking about calling a function we can consider as a higher order function. A higher order function is a term from functional programming. A higher order function is a function that either it is a function that takes a function, so when you invoke it, you pass over a function, or a function that returns a function, or both. And when talking about a function, a higher order function that takes a function, it is actually about the higher order function that when you invoke it, you pass over a reference for an object that represents a specific function. So in the case of Kotlin, it would be an object from a class. If you're using a Lambda expression, it would be an object from a class that is auto-generated for you underneath, and the method in that class that is defined is in accordance to the Lambda expression, and eventually the reference for the new object instantiated from that class, this is the reference that is passed over to another function. And the same case when a function returns a function. When a function returns a function, it is actually about a function that returns a reference for an object that represents a function. And in the case of Kotlin, in Kotlin, it will be a reference for an object instantiated from a class. Happens underneath indirectly, and that class includes the definition for a specific function. And by getting back from a function you invoke a reference for such an object, you can actually invoke the method on the class that that object was instantiated from, and that object is actually the object that represents the function. Okay, now let's talk about function type. Okay, now let's talk about what a function type is. In order to understand the use of Lambda expressions in Kotlin, you must be aware of the possibility to create a type known as a function type. A type that when having a variable that this is its type, it is possible to assign that variable with a reference for an object that represents a specific function. And the way for us to create a new function type is very simple. Take a look at this code, for instance. Over here, we have a variable, its name is onLoad. This is its type. And you can see by this specific text that it is a type, it is a function type, that every function that matches this type is a function that doesn't have parameters and doesn't return any, or let's say returns a value of the type unit, which is nothing. So the way for us to create a new function type would be placing the types of the parameters in parentheses on the left side, and then specifying the type of the return value of that function that will be that will match our function type. So when you have a variable that this is its type, it is possible to assign that variable with a reference for an object that represents a function that its signature match the function type. It can also be a function type that is actually a function type that has a receiver. For those of you who are familiar with that, a function type that means, in this case, for instance, every function that match this type is a function that its returned value is of the type C. It is a function with one parameter of the type B, and it is a function you can invoke on object of the type A. For those of you who are familiar with functions with the receiver. You can also, for those of you who are familiar with the possibility to use the suspend modifier when working with coroutine, then of course, when creating a function type, you can add the suspend modifier, and then it will be clear that it is a function type, that every function that match it should be a suspend function. But I don't get into that topic. This is beyond our scope. It's not related to our meetup at all. You can also create a type alias, which makes things simpler. For instance, just specify on the right, the description for the type, function type, and then using the type alias keyword, we just say that from now on, whenever I use the type calculate, I actually use this specific function type. You can also add parameter names to your description for the function type. If it helps to the readability of your code, then of course go and do so. And you can even combine function types. For instance, over here we have a function type that describes a function with one parameter that its type is int, and the return value is actually a function, or to be more precise, a reference or an object that represents a function, and it should be a function that its signature match this specific description, this specific function type. We can do so as well. Now, how can we instantiate, or let's say, how can we create an object that its type will be a specific function type? So we could then take the reference for that object and pass it over as an argument to an higher order function we invoke, for instance, or define a function that its returned value is a reference for that object we created, an object that we can say about it that it is an object that its type is a specific function type. Well, very simple. We can use a Lambda expression, and in Kotlin, we use a Lambda expression using this specific syntax. Don't forget the curly braces. in the beginning and in the end. It's unique. It is unique for Kotlin. I didn't see that approach in other programming languages. This is a Lambda expression. This specific Lambda expression is a Lambda expression that describes a simple function with two parameters that if you invoke it, the return value is the total of the two values you passed over. This is what this specific Lambda expression describes. Now, underneath, we shall see that this expression, its value, we shall see that shortly. This expression its value is actually a reference for an object instantiated from a class that is auto-generated for us underneath a class that implements the specific function type we described, or the specific function type we are using. We can also use another syntax instead. This is another option for getting an object that represents a function. This is the anonymous function syntax. If you're familiar with, we can go with that, but our meeting is about this specific syntax, a Lambda expression in Kotlin. Well, we could do it by ourselves and declare a class that implements a specific interface, which is the function type we're talking about, and then assign a reference for a new object instantiated from that class to a variable that its type is the function type we're using. We could do so, and if we're doing so, if we want to do so, then it should look like that. This is actually the code that happens underneath when using a Lambda expression. If you don't want to use a Lambda expression, then this is the way for doing things. You will just define a class, call it whatever you want, then specify that the class implements a specific function type, and implement the function invoke. That's all. That's all. Then you can instantiate the class, assign the reference for the new object to a variable. From now on, you can use this variable as if it was a function. Because in Kotlin, when having a variable that holds a reference for an object that its type is a function type, you can simply use parentheses like this just for invoking, calling, executing the function invoke on that specific object. Your variable holds its reference. So we could do so. It is a difficult way, or alternatively, we can use a Lambda expression. Using a Lambda expression means that underneath, this is what happens. Underneath, there is a new class instance that is auto-generated for us. It implements the function, the function type we're talking about, we're using, and an implementation for the invoke method is exactly according to the Lambda expression we code. Or we can, so there are two ways. This is the way that usually we don't choose. We usually prefer to write a Lambda expression, but this is exactly what happens underneath when using a Lambda expression. Okay, so let's move forward. Well, compiler inference is the ability of the compiler to understand what is the exact type of a variable. And I believe you are already familiar with that in Kotlin. As you can see in this case, if you have a Lambda expression, it's this one. This is a Lambda expression. It is a Lambda expression that describes a very specific function. It is a function you invoke, pass over a number, and get back the number +1. Over here, f, the variable f is actually assigned with a reference for a new object instantiated from a class that implements the function type that match this signature. And the implementation of the invoke method is exactly according to what you see over here. So you can use the variable f for calling the function by using the parentheses, as in this case, or by invoking the function invoke. Both ways are fine, but usually we invoke the function using the parentheses. We don't go and call the invoke method. It doesn't look good. If you have a function type that as a receiver, then you can interchange between that type and a type of and a function type that has an additional parameter that its type is the type of the receiver. I will explain. Over here, we have in line 1, f1 is a variable. Its type is this specific type, meaning that you can assign, f1 is assigned with a reference for an object that describes a function. It is an object instantiated from a class, auto-generated class, a class that implements the function type, this specific function type, and the implementation for the function invoke is according to whatever you see over here. So f1 is actually assigned with a reference for an object that represents a function you can invoke on a string object. You pass over a reference for an init object. The return value is its type is string. Well, you can assign the reference you have in f1 to the variable f2, even though the function type over here is different. But because, as you can see, the type of the receiver is shown as an additional parameter in the function type described over here. So basically, when you have a function that as a receiver, you can treat the function as if it wasn't a function with the receiver, but it has an additional parameter as a replacement for the receiver. So these two types are interchangeable, just to know. Okay, so as we saw before, there are two ways. We can either use the parentheses, and this is the preferred way, or we could go and call the invoke method. Those two options. And of course, we usually use the parentheses, no question. Okay, next. There is a term in programming languages and also in Kotlin, function literal. Function literal is something you can take and pass over. And when you write a Lambda expression in Kotlin, here is the Lambda expression. Here is a code you probably know. This is a demo for calling a function that its name is max. It is a higher order function. It takes as the second argument a reference for an object that represents a function. In this case, I pass over a Lambda expression, which means actually that I pass over a reference for an object that represents a specific function, because it is an object, as we showed before, that was instantiated from a new class that implements the function type we're dealing with, and the implementation for invoke is in according to the Lambda expression we have, and then the function max does something. Find us the max number, for instance. Find us the, in this case, it's just a sample. It's not something to run, to execute. Okay, next. Now, let's talk about the syntax. The syntax, as we saw before, is very simple. In order to create a Lambda expression, we use the curly braces before and after. As I said before, this is something, the curly braces, I haven't seen the use of them in the context of Lambda expression in other programming languages. Those of you that come from other programming languages, don't forget those curly braces, because otherwise it won't work. And this is the main difference comparing with Java, comparing with many other programming languages. Okay, in this case, f is assigned with a reference for an object that represents this functionality, and as explained before, it is an object instantiated from a class that implements the function type, and the implementation for invoke is according to what we have over here. Over here, yes, and this is a simple Lambda expression that describes a simple functionality, a function that takes two numbers and returns their sum. Okay, next. If the return type of the Lambda expression is not unit, then the value of the last expression within the those curly braces will be the return value. So in this case, for instance, sum is a variable. Its type is a very specific function type that describe functions with two parameters of the type int and the return value of the type int. And sum as variable is assigned with the value of this expression. The value of this expression is, as explained before, a reference for an object instantiated from a class that implements the function type we're dealing with. And the implementation of invoke is exactly according to whatever is described over here. And whatever is described over here, so pay attention to the fact that we don't have the return keyword. When having a Lambda expression, then and you don't see the return statement, then the value of the last expression, you see in this case the value of the variable result, this is the return value. Okay, this is it. Next. Now I want to talk with you about something that I believe that many developers during their first step with Kotlin find a bit irritating. And I mean the possibility to pass over a Lambda expression, and you know the meaning. It is about passing over the reference for the object instantiated from the class, blah, 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 blah. Passing over the Lambda expression to a function without placing the Lambda expression within the parentheses of the function. Here in this sample, do something is a function with two parameters. The first parameter is assigned with 0. This Lambda expression is passed over to the second parameter. Just imagine that instead of having this small this small character over here, we have it over here right after the Lambda expression. Just imagine having the Lambda expression as an argument we pass over to do something together with the argument 0. So bottom line, when you have a function that its last parameter, its type is a function type, you can invoke that function and pass over to the second parameter a Lambda expression. And instead of writing the Lambda expression within the parentheses, write it outside. It is the same. This is something I can't guess for what reason they chose, but to allow that. But this is the key for understanding many code samples you might find when using Kotlin, when you use various frameworks. In many cases, you will see a call to a function and you will see the Lambda expression that is passed over outside of the parentheses. So it is just as if we were putting the Lambda expression inside the parentheses. It is the same, exactly the same. Okay. Now I'm going to talk about the it implicit parameter. This is also something unique for Kotlin. They took a decision to allow us writing a Lambda expression in a unique syntax for Kotlin without having the arrow and the left part of the arrow. For instance, this Lambda expression is a Lambda expression that describes a very simple functionality in which a value is passed over to that functionality, and we get in return true or false. All depends on whether it is even or not. So when you see this special word it, then just treat the expression as a Lambda expression, and think about that underneath a new class that implements the required functional interface. Just imagine that underneath a new class is auto-generated for us, and that new class implements the function type we are dealing with, and the implementation for the function invoked in that a new class. We don't see it. It happened underneath. The implementation for invoke is exactly according to what you see over here. So eventually, the value of this specific expression is a reference for a new object that describes a specific functionality, and that's why we can pass over the value of this expression as an argument to the filter function. One more thing unique for Kotlin is the possibility to take a function, a real function we define in Kotlin. And just remember that in Kotlin, a function is not an object, just as in Java. And if someone tells you, and you might hear that, because I think I saw that in the documentation even in the documentation itself. If someone tells you that in Kotlin, a function is a first-class citizen, which means that a function is an object, it's not true. A function is not an object, just as in Java, just as in C#. By the way, in Scala, a function is an object, like in JavaScript, PHP, Python, but in Kotlin is not. So if you have a function and you want to get a reference for an object that represents that function, or in other words, you want to get a reference for a new object instantiated from a class that implements the function type we're dealing with, and that object will be actually from a class that includes a definition for a method that does exactly whatever is already implemented in a specific function. Just write those two columns with the name of that function. This specific expression that I'm now marking with a blue background, gray background, this specific Lambda expression, its value is a reference for an object instantiated from a class that implements the function type we're dealing with, and this is the function type we're dealing with. And that reference for that object is assigned to f, which means that we can later treat f as if it was a function and invoke that function either using this syntax or by calling the invoke function we showed before. So two columns operator, also something you should be familiar with. Another style you might want to know about is the underscore. If you describe the Lambda expression and there's here I can see that this parenthesis is missing, it's a typo. If you want to create a Lambda expression and there is a parameter you're not going to use, you can just place an underscore. This is fine. It improved the readability of our code. And that's it. Yes, I even managed to finish it in a few minutes earlier. Okay, so now I'm with you. I will be very glad to answer questions and any question you have, of course, about our specific topic for today, but it can also be about other topics in Kotlin in general. I'm with you, please. You can also ask using the chat if you're interested.
Just a quick question, right? So is it okay to ask? Yeah.
Yeah, please. I'm listening.
So just wanna, I mean, I understand like Kotlin is like object oriented as well.
Yes.
Language. So same like Java. So how important or how much involved is the functional side of it? Like, because I think as you mentioned as well, we can use anonymous functions if you want to use any functionality. You know, in like object-oriented programming. So how much you think we need lambdas or something in object-oriented programming? Like how much is useful?
I'm not sure that I got your question. You asked about the need for Lambda expressions in object-oriented programming.
Yeah, I mean, in a sense that how much we need in in production, sort of like I haven't worked a lot in the industry, so that's why I'm a bit curious, because usually Java and Kotlin they're object oriented. So we try to make objects and try to uh, do the programming in that sense. So sometimes we need like function part of as well. So how much we need of in object oriented side if you want to do.
Well, I hope that I managed to understand you correctly. The definition for object-oriented programming paradigm, functional programming paradigm, and so on are very theoretical. In practice, you can find more and more object-oriented programming languages adapt themselves to concepts coming from the functional programming paradigm. The separation between those paradigms is not clear-cut. Pure functional programming is a great topic to learn in the university. When dealing with practical work, when dealing with developing systems, eventually we can say that the entire industry is based on the object-oriented paradigm. And it is just a question which concept from functional programming, adopting them will do good, will improve our code, will allow us to write shorter, more readable code. And using Lambda expression makes things simpler, because using Lambda expression, it can be in Kotlin, it can be in Java, allows you to write a more readable code. So even though not every company is in a run to adopt the use of Lambda expression, and you can still see places where they still don't use Lambda expressions. On the other hand, you can see more and more companies using that possibility. And it is, and I'm talking mainly about what happens in the Java ecosystem. Now, if you're talking about Kotlin specifically, then usually companies that adopt Kotlin and start using Kotlin on the server side use Lambda expression and use them a lot. And the main reason, because it helps to create a more readable code. It helps to create shorter code, and this is good.
That's fine. Thanks. Just as you mentioned, that a lot of companies that are following object-oriented paradigm, they are following functional side as well. So could you give me some example? Like, let's say if you're building a banking application using object-oriented side of it, so how are you adopting functional side in that?
In systems that in their nature they are a simple information system, and in the banking industry, most systems, if you think about a bank that allows its customer to access the account and perform various operations, this is a system that in its nature, it is an information system, simple information system using functional concept, or using concepts from functional programming might be less dominant, but yet you can see, for instance, lots of companies that do their server side using frameworks that allow them to work in asynchronous way, and when doing that, immediately you start using Lambda expressions. Banking, if you talk about simple platform for simple systems for users to access and get information about their accounts and so on, I can't see. Let's put it in different words. I believe that in most cases, the pace of adopting new technologies, new concept, new functional programming concept might be the pace itself will be different comparing with a startup that starts developing a new platform that needs an amazing performance and so on. But still, as I said before, when a company, even a company that develops a simple information system for a bank, moves to a server side that work in asynchronous way, bang, you start using Lambda expressions and a lot, usually. And talk about the Java ecosystem. In Kotlin, in any case, always, you will see in every framework use in Lambda expression. I can't think about someone writing in Kotlin, especially for Android, but also on the server side, not using Lambda expression.
Cool, thanks.
I hope that this is what you meant in your question. I'm not sure.
Yeah, that's fine. Thanks.
Okay.
If I may add something, there are some banks using Scala.
Yes.
I think ING does that a lot. And I also found some job in Haskell for trading because I need something that has to be mathematically proved, and functional programming is really good at that.
Yeah, in general, you can say that in the finance world, you can find very clear dominance for functional programming and the samples you gave. But this happens usually when in a more sophisticated system. The simple systems of a customer accessing his background, this is a simple system. Usually, I believe that most banks are not in a rush to replace their server side that works fine with the servlets and JSP to a new framework that works in asynchronous way and start pushing forward to adopt a new concept from functional programming. I believe it happens here and there, but not in a massive way. On the other hand, those samples you gave for finance systems, sophisticated ones, especially those that work in real time, those that are developed using Scala, using asynchronous server-side frameworks and so on, it's a different story. You'll find lots of functional programming. Today, 2021, I believe that in every programming language, especially in JavaScript, you see that a lot. But not only, also in other programming languages, it happens in all of them. All of those dominant programming languages, you find an adoption for concepts coming from functional programming. It's a topic. It's a topic. It's not enough just knowing object-oriented. No, you should know topics from functional programming. It's not a huge topic. It's not. Well, it depends how you learn it. By the way, the next meetup is about design pattern. Not a simple one, but a very interesting, in my opinion, one of the most appealing ones I found during the last 2 or 3 years. Combinator. Just take a look. The next meetup is about a specific design pattern. We shall cover it in Java. You can Google for it. It is a very nice one, and knowing it, of course, can allow you to improve your code, to create a more readable code. Eventually, the bottom line, and you see that a lot if you develop in Python, you can do that a lot, but also in other programming languages and Kotlin as well, and Java, of course. When we succeed writing the same program, but having a more readable code or smaller code, then it is a preferred option, because when having a smaller code, it is simpler to maintain. Simpler to maintain is important for us, because maintenance is the main work in the long run. The only problem is when having a team where not everyone is a sharp developer that understands exactly what happens when you have junior developers in your team, and your team needs to maintain a specific system. Then it might be a better choice. Well, it is up to the management to decide, but it might be a better choice to avoid topics that are too complex to understand, as adoption of concepts from functional programming, for instance, as implementing the combinator design pattern I'm going to cover next meetup. So
in some cases, you can do some pair programming just to learn new things when you're not very good at a language. With a seasoned developer, it could be a solution to learn how to do some very complex functional programming things. And I think it's possible even with beginners to raise the level and to have a winning team. But of course, you need an agile team and so willing to do sometime pair programming, and it's in the culture of the team that you have to implement that.
As you say, it is possible. I agree, but you should be very careful with if you are a manager taking a decision. You should, because there are various developers, and I see that a lot. I deliver trainings in many IT companies. I do so for 20 years, and it is amazing the difference between one company to another. Of course, I don't say anything. I don't say a word. But after visiting so many IT companies and see so many developers in different levels, I think it is a must to consider very carefully decisions to move forward with more sophisticated topics. By the way, one of the difficulties Scala has is the very difficult learning curve. The learning curve. The learning Scala is way more difficult than comparing with Kotlin and of course Java. And I know many companies that avoid Scala for that.
Yeah, it's really difficult. I tried
Very
that
difficult,
in the past and
difficult.
I gave up. Yeah.
Look, Scala is a strong language, a very strong programming language. The tool set is amazing, but the documentation, sorry, is not as good as in. Well, the one in Kotlin also isn't the best. It's not MSDN for Microsoft. For those who are familiar with MSDN, this is the best. But still, the documentation in the case of Kotlin is much. It is better. It's better comparing with what you have in Scala, and the topics themselves are simpler. It is a simpler programming language compared with Scala. So in many cases, I say you don't want to stick with the old Java. You want to move forward. I understand. Do it with Kotlin. If you are afraid that Scala will be too much for the team.
Yeah, it's a really nice language because it's very expressive, and you have the null check, and there are plenty of very interesting things in Kotlin.
Absolutely, you don't need to convince me.
I'm sure.
Scala, I'm with Scala since 2009, but I see what happens in the real world in companies, and I know more than a few companies that stay away from Scala, mainly for the difficulty to find developers, mainly for the difficulty to train, to teach developers to know Scala. The companies hardly find developers that know Java properly. I see that all the way. In Israel, the problem in Israel that people can't come over as in the United States, get a visa permit and start working as developers. Only recently they started to allow that. And because of that, there is a shortcut in developers, and people and companies have a huge difficulty to hire new software developers. So going for Scala or Kotlin is not practical. Stay with Java. And I see that happens in many companies.
It's a risk. It's true. It's a risk.
In Israel, if you check how many people work in the IT industry in Israel, it's amazing. I mean, nearly everyone has some touch to any specific company. Lots of people work in the IT industry. This is the locomotive of the economy here in my country, and there are companies with difficulties to find developers, and the salaries go up, and this is a problem, and the salary continue to go up, and it's very similar to what happened in this, nearly what happens in Silicon Valley, and this is a huge problem for high-tech companies. So going for Scala, many companies prefer to avoid that. By the way, I see another Marco. Where are you from, Marco?
Sorry. You hear me?
Yes.
Oh, I live in Prague. I'm from Croatia.
Oh, Prague.
Yeah.
It's the homeland of JetBrains.
Yeah, exactly. Yeah, I was just browsing, and I saw I saw that you're gonna have this webinar. I thought I'm gonna join. Came in late. I didn't figure out you're in Israel. Sorry about that. You know, there was a time difference. So.
I'm so excited. We have people. Well, some people have left, but we have people from all over the world. It's amazing. So you work in JetBrains, by the way.
No. I work as a programmer here in Czech Republic in a bank. Yeah, we're not using functional programming. It's was like the question. We're using like standard object-oriented Java. I would have a question.
Yeah.
It's not related to Lambda expressions, but it's related to extensions in Kotlin. I find it a little bit like, well, it's very, very convenient. Basically,
you talk about extension function.
Yeah, exactly.
Okay.
Yeah, and I mean, it's like it's really, really convenient. You can just like basically extend the class and use that function and so on. But yeah. I find it like it's breaking my programming habits.
Yeah.
And that, you know, I was like, I'm inheriting something and then I'm saying, okay, I made a bad design here, but I can write an extension function and get away with it, you know? And some repos that I saw, like, you know, a lot of people, I have a feeling that a lot of people, and I'm not good at programming in Kotlin, are not good at programming in Kotlin because, you know, it has so many functionalities, but people, I think they just misuse them.
Yeah. Well, you said it. I can't say it better. Just use them. It is a problem I know from .NET, by the way. By the way, extension function is not something new for Kotlin. We have it in C# for years. And just as in C# and in .NET, I saw many developers just using something without exactly understanding what exactly happens underneath. And this is something that happens a lot when you take a look, and it happens a lot with developers that develop in C# .NET. I agree with you. I believe that many developers just use those candies, those sugars, synthetic sugar surprises that Kotlin has to offer us, and they don't understand exactly to the end exactly what happens. Yeah, and it is a bit annoying to see something like that, the extension function, without having any previous experience with something similar. And I believe that you didn't see that before in other programming languages such as C#. So it was a bit surprise for you. Am I correct?
Yeah. I mean, Java doesn't have it, and I'm programming databases, PLSQL, and so no, this was Kotlin was the first thing that I actually saw something like that possible.
I believe many share with you the same feeling, and the same feeling. Yes, but eventually, bottom line, when you put all of that aside, it helps you to develop a smaller code.
Mm-hmm. Yeah, of course.
And this is good because a smaller code, less code to go over, simpler to understand for new people that jump over the boat and join our team. It is a good thing, I believe. But you know, there are many things in Kotlin that in the beginning it's a bit difficult to adopt.
Well, I mean, the language is very, very flexible. I mean, you mentioned that example that if you have like a functional literal at the end of the function, you can basically omit it from the round brackets and just put it in the curly brackets. And then I don't know, if you're not using a parameter, you can like underscore it. That has a name as well, you know, and it's just kind of like killing the readability of it. You know, like, oh, you can make it more concise. You can make it more concise. With, I don't know, with IntelliJ like idea, you know, it's basically helping you out. You know, all you got to do is like press Control Shift Enter. You know, and it's helping you out. You know, it's filling the names of the functions if you're invoking something and so on. You know, so I don't get why is this demand for such conciseness. I mean, but that's overall in programming. You don't have to answer that.
No, I don't answer that. I'm not going to answer that. I can also say that in programming in general, some stuff is black and white and no argue about. And there are lots of other stuff which is in the gray zone, and people might have different opinion. And I don't know what was the main motivation for each and everything, every bit of what Kotlin has to offer us. I know that Kotlin was developed by developers in St. Petersburg, developers that work for JetBrains. That's all I know. I know that it is clear that they felt that there is something missing in Java on the one hand, and on the other hand, Scala was maybe a bit too difficult to adopt, and maybe this was the window of opportunity for them to go in between, because Kotlin takes a lot of stuff, copy or is inspired, I believe, by Scala a lot. So this is my feeling. Let's make something simpler.
So, like, just a quick one. I mean, when the Marco is mentioning that extending function is talking about extending function, is he talking about Lambda expressions? Yeah. Or?
No, it's not. It's not. Doesn't belong. Extension functions is a topic, a separated topic. It's not. Doesn't belong to Lambda the expression. I refer that in a specific slide, that's all, but it's a separated topic. It's just think that there is a type that was already defined and we want to have one more or two more. We want to have more methods that it will be possible to invoke on objects instantiated from that type, but we don't have the code for that type. And now the language allows you to define a function as extension for that type, as if you add the access for the code. So this is, it helps you to create shorter code, smaller code. Okay. That's all. I'm very sorry for the beginning when I forgot that I didn't share the laptop, the screen of my laptop. And very sorry for that. I will later tonight or tomorrow, I will arrange the slide. I will also fix that specific slide that somehow was in the wrong position. And I will arrange the video for you as well. I will send you a detailed message through the Meetup platform together with a coupon that will allow you free access to the 2 conferences I'm working on. They should take place by the end of the year. One is in November, the other in December. I also want to invite you to the next meetup about the combinator interface design pattern. And that's it. And of course, if you enjoyed, please forgive me for the beginning when I didn't notice my fashla, my mistake. If you enjoyed, I will be very happy to get your feedback. You can also, you should get a questionnaire from the Meetup platform. It helps me because I do those meetups for free, but I hope that somehow this will generate more work for me. And I also enjoy this is the truth. I enjoy. I thank you all for joining.
Can I just
from
ask
all over
something?
the,
Is
sorry?
it possible? Is it possible? I came in late. You were already like on page 20. Like well, actually came for the end. Is it possible to get the presentation sent by
Yes, yes, yes,
email?
of course. I will. This is exactly what I said. I will arrange the presentation, the slides,
Excellent. Thank you.
and the video and the coupons, so you can join or register for free to the two conferences I'm working on, and some a bit more stuff. I will send you everything through
Thank
the
you.
Meetup platform. Okay.
What is the next meetup about the design pattern you mentioned?
Yeah. You can find more info about that in the. If you go to the Life Michael on Meetup and you check the upcoming events, I believe that you will see the Combinator design pattern. It will take place on next month, July 6th. You can Google for that pattern. You will find here and there a few articles. It is a nice design pattern, relevant for Java, Kotlin, many programming languages, and as many other design patterns. It is a solution for a specific problem. It is a solution that the bottom line is it allows you to write a smaller code for attacking, for solving the problem this design pattern was developed for. So I strongly recommend you. This one might be very interesting for you. The next one, I don't know. If, usually people that do Kotlin don't do front end usually. So, and of course, I will be very glad to be connected with you over Facebook, LinkedIn. I will send you links for that. We're very glad to be connected, stay connected. And that's it. Are there any more questions? Anyone? Okay, so I will say good night and take care and take care after yourself, especially those of you who are still in places with corona all over. Just be careful, and that's it. Good night.
Good night. Thanks for the.
Hey, thank you very much. Goodbye.
Bye bye. Bye bye.